The radiation starts killing the spacecraft long before it reaches the clouds. Invisible waves tearing through electronics, corrupting memory, burning circuits apart atom by atom. Inside the probe, systems begin shutting themselves down to survive. Outside, Jupiter fills half the sky. A storm larger than Earth rotates silently beneath layers of orange and white cloud. Lightning flashes deep inside the atmosphere. Not like lightning on Earth, these bolts are powerful enough to illuminate entire regions of the planet at once. And somewhere below those clouds, NASA found something they were not expecting. For decades, Jupiter looked simple from a distance. A giant ball of gas, hydrogen, helium, storms near the surface, a dense core hidden below. But distance hides detail, and Jupiter hides things better than almost anywhere else in the solar system. By the time Juno arrived in 2016, the spacecraft had traveled nearly 3 billion kilometers through space. 5 years moving toward a planet humanity still barely understood. Then, the engines fired. For 35 minutes, Juno slowed itself just enough for Jupiter's gravity to capture it. If the burn failed, the spacecraft would disappear forever into deep space. If it fired too long, Jupiter would pull it down into the atmosphere and crush it. Everything had to happen perfectly beside the largest planet in the solar system, and it did. Juno entered orbit around Jupiter, moving faster than almost any human-made object in history, straight into the most hostile planetary environment humanity has ever attempted to study.
The radiation surrounding Jupiter is so intense that a human near the planet without protection would die almost instantly. Even machines struggle to survive there. Juno carries its computers inside a titanium vault, built like an armored bunker, walls nearly a centimeter thick, protecting the spacecraft from radiation storms strong enough to destroy ordinary electronics within hours. And even then, Jupiter is slowly killing it. Every orbit damages the probe a little more. Every pass through the magnetic field strips away its lifespan. NASA knew that before launch. They sent it anyway, because what existed beneath the clouds mattered more.
At first, the planet behaved as expected. Cloud systems, cyclones, jet streams moving hundreds of kilometers per hour. Then Juno measured Jupiter's gravity, and the numbers stopped making sense. The planet's interior did not match the models. The core was wrong. Not missing. Worse, broken. Scientists expected a dense center buried beneath the atmosphere, a compact planetary core holding everything together. Instead, Jupiter's core appeared diluted, spread outward into the surrounding layers like something had shattered it billions of years ago. Not a solid sphere, not a stable center, a partially dissolved mass stretching through nearly half the planet. That should not happen naturally. Planetary cores are supposed to remain intact. Worlds form around them. Gravity pulls gas inward toward a stable central structure. Jupiter looked like something had disrupted that process, violently. One possibility emerged almost immediately. Another planet. A massive collision during the formation of the solar system. A world perhaps 10 times the mass of Earth slamming directly into Jupiter shortly after its birth. The impact would have released enough energy to destabilize the core and scatter heavy material upward into the surrounding hydrogen. The evidence fit disturbingly well. Jupiter may still carry the remains of an ancient planet inside itself, buried beneath 50,000 kilometers of atmosphere. And Juno kept finding more. The spacecraft passed over Jupiter's poles. What it saw there did not resemble weather. It resembled structure. cyclones the size of continents rotating beside one another in perfect geometric arrangements, 8 surrounding one at the North Pole, 5 surrounding one at the South, locked together, stable, persistent. Storms on Earth collapse after days. Some on Jupiter survive for centuries. The Great Red Spot alone has existed longer than modern civilization. A hurricane large enough to swallow Earth whole. Winds exceeding 600 kilometers per hour. And even that storm is changing now, shrinking slowly after centuries dominating the atmosphere. Jupiter's weather behaves less like climate and more like a living system, constantly shifting, constantly feeding itself. Then Juno looked beneath the clouds, not visually, deeper than light can penetrate. Microwave instruments scanned hundreds of kilometers downward into the atmosphere, and the storms did not stop. The colorful bands visible from space extended far below the cloud tops, jet streams reaching thousands of kilometers deep into the planet. The atmosphere was not shallow. The weather itself was part of Jupiter's internal structure, an entire planet moving like fluid. Then came the pressure. The deeper inside Jupiter, the stranger matter becomes. Hydrogen gas compresses under forces so extreme that the atoms begin collapsing together. Electrons break free. The gas transforms into liquid metallic hydrogen, a form of matter almost impossible to produce naturally anywhere else. A liquid that conducts electricity like metal. This ocean of metallic hydrogen may be larger than every rocky planet in the solar system combined. And moving through it, electrical currents generate Jupiter's magnetic field, the strongest planetary magnetic field in the solar system, so large that its magnetic tail stretches beyond Saturn's orbit. If that field were visible from Earth, it would appear larger than the moon in the sky. Inside it, radiation storms powerful enough to tear apart spacecraft systems from millions of kilometers away. Auroras erupting around the poles brighter than anything seen on Earth. Entire regions of the planet glowing in ultraviolet light.
And then there was the ammonia. Something about its distribution made no sense. Certain regions contained far less than expected. Others dragged ammonia deep beneath the atmosphere before pushing it upward again in violent circulation patterns scientists still cannot fully explain. The deeper Juno looked, the less stable Jupiter became scientifically. Not physically, conceptually. Because planets were supposed to be understandable. Rock, gas, gravity, structure. Jupiter exists somewhere between categories, too massive to remain simple, not massive enough to become a star, a failed star carrying storms larger than worlds and oceans made of metallic hydrogen. Even now, Juno continues orbiting Jupiter, passing through radiation, scanning the storms, mapping gravity distortions hidden beneath the atmosphere. Each orbit sends more information back to Earth, and almost every discovery creates new questions. Because Jupiter is not becoming easier to understand, it is becoming stranger. Beneath those clouds, matter changes state. Storms survive for centuries. Lightning flashes through ammonia ice clouds taller than continents. And deep below it all, the largest planet in the solar system may still carry the remains of an ancient world dissolved into its interior. Jupiter is not merely a planet. It is something closer to an abyss, a place where the deeper humanity looks, the less familiar reality becomes. Subscribe, because the closer humanity gets to Jupiter, the less familiar the universe becomes.